Dear learners of control systems, hope you would have enjoyed my video on MATLAB simulation. So I have explained to you how to create your own login in the MATLAB online version provided by the MathWorks, and how to write a simple program for finding the step response of a first order system when the closed loop transfer function is given. So that is what we have seen in the last video. That is, we have to go to the MATLAB program. So in that MATLAB program, we have to type and then execute. So this we have already done. So we have simulated that and we have understood what is that. So how to understand the time constant significance. We have already captured some information and we grasped something on the time constant. Now we will explore further. So let us see how to understand the time constant if the open loop transfer function is given. Right. So if the open loop transfer function is given, how to find out the closed loop transfer function and then understand the significance of time constant. So for which two programs we need to execute. One for open loop transfer function 1 by s plus 1, another for the open loop transfer function 1 by 2s plus 1. So we have to simulate the results in both the cases, find the time constant and then compare the time responses. So let me take the first one. So in that first one I am typing the program. So this program I am typing. So this program, because I have to have 1 by s plus 1. So that means numerator should be 1, denominator should be 1 and 1. Then I am assigning 1 by s plus 1 as the transfer function for a variable sys for. Feedback for transfer function is assigned as 1. In order to understand the nomenclature according to our convenience, we have given sys for, that is forward for transfer function, sys feedback for transfer function. Now these two should be actually included in the system transfer function by feeding back the output through a unity feedback. So therefore, feedback is the keyword. Within brackets sys for comma sysfeed sys is the variable assigned to the closed loop transfer function. Let us understand this. So first let us run this. So we get some response. Before that, I go to the command window. So I just put CLC, clear the screen. Now what I do is I type SYSFOR and then I am just putting enter. That means I get 1 by s plus 1. For example, I type SYS feed, I get feedback for transfer function as 1. For example, I type SYS, that means G of s by 1 plus G of s h of s. So G of s by 1 plus G of s h of s is 1 by s plus 2, because 1 by s plus 1 by 1 plus 1 by s plus 1, that is what we get, right? G of s is 1 by s plus 1. So 1 by s plus 1 divided by 1 plus 1 by s plus 1. So that is 1 by s plus 1. So for this closed loop transfer function, if you find the time response, you get like this. Here you can find that the final value, this is the final value. So it is finally settling down to 0.5. So since it is settling down to 0.5, there is an error. There is an error of 0.5. So that means the type 0 first order system tracks the input with 0 steady state error. Why do I say it is a type 0 system? So in order to understand that type 0, type 1, all that, so you should go to my channel. So Dr. C. Ganesh teaching modules. So you type Dr. C. Ganesh teaching modules. So in that you can see the playlist. So in that playlist, control system lecture series, you can see that. So in that error and steady state error is there. So control system lecture series error and steady state error. So here I have explained to you very clearly about the type and order. So that you can probably go through before coming to this video. Now coming back to this, so it is a type 0 system because the pole available at the open loop transfer function is not at origin, it is at a place other than origin -1. So we call it type 0 system, type 0 first order system. Type 0 first order system, there will be always an error. Now I am finding the time constant. What is the time constant? We know that by the definition. What is the time constant? It is the time taken by the system response to reach 63% of final value. That means 0.5, 63.2%. 63.2% means you will get something 0.31 something. Anyway, that I have already simulated and I can show here 0.316. It is amplitude is 0.316. So for that I am getting 0.5 second. That means at 0.5 second I am getting, you can see here closely, you see that 0.316, yeah, something close to 0.5. So that is what I have put here. Now what I do is, now I change the transfer function from 1 by s plus 1 to 1 by 2s plus 1. So what I should do? So here I have to change 1 as 2. Now I have to run. Now I am running. See, now how to check whether the transfer function has been changed? So go to sysfor, just type sysfor, enter. So you can see 1 by 2s plus 1. Yes, that is what we have to have now, 1 by 2s plus 1. So after checking that 1 by 2s plus 1, we need to check our closed loop transfer function sys. So you can find here the closed loop transfer function is 1 by 2s plus 2. So earlier the closed loop transfer function was 1 by s plus 2. Now it is 1 by 2s plus 2. So you can see the steady state output is 0.5 only, but the time taken to get that 0.316. So 0.316, how much time it takes? So it takes close to 1 second. So that is what I have put here. So this I have already simulated. See here. So the same, that 63.2% of final value, how much time it has taken? 1 second. So I have increased this S coefficient from 1 to 2. That means my time constant has also increased from 1 to that is a 0.5 second to 1 second. That means more the time constant, it takes more time for my system response to reach the final value. So that is what I have given the results. So type 0 system step response is done. So time constant is 0.5 second. Yeah, first system it is 0.5 second. So steady state error is there, yes, that I have explained. So 1 by 2s plus 1 open loop transfer function, if you see, the time constant is 1 second, the steady state output is 0.5. So the steady state error is 0.5. So if we compare these two simulation results, what is inferred is, the transfer function 1 by s plus 1 in open loop yields a time constant of 0.5 second, whereas the other transfer function with OLTF 1 by 2s plus 1 is said to have a time constant of 1 second. Therefore, the second system with the open loop transfer function 1 by 2s plus 1 is slower compared to that of system 1. So even though their steady state outputs remain the same, the time constant has affected the speed of the response. Therefore, what is understood from here is time constant is indicative of speed of the system response. Thank you.